The properties we're going to learn in this lesson or use for these sums are the following. Here is a circle with center O. And we have a chord. We have P and Q, 2 points on the circle. And from these 2 points, I can draw a number of angles. If I take a point A here on the circle, here I can draw one angle. So this angle is said to be an angle at the circle. So angle PAQ is angle subtended at the circle. Now the same arc subtends an angle at the center, and the angle at the center, to draw the angle at the center, we join P and Q to the center. This is the angle at the center. So angle POQ is angle subtended at the center. These two angles are related. If this is x, this is double of it, that is 2x. Or you can say PAQ, angle at the circle, is half the angle at the center. This is subtended at the center. Here again is a circle with center O, and these are 2 points P and Q, and when I join P and Q at to the center, you get this angle. Now the angle at the center here, I can mark, this is the angle at the center. Corresponding to this, you will have angle at the circle, and the angle at the circle will be behind it. Say B. This is the angle at the circle. Now if this is x, this becomes 2x. So maybe I put it y. If this is y, this is 2y. So angle PBQ is angle subtended at the circle, and angle POQ, and I will call it reflex angle, is angle at the center. And again, the angle at the circle is always half the reflex angle. To recap, we have a circle with center O, and we have these 2 points, say P and Q. And if I join PQ, here I have this angle. And this angle, say angle POQ, will always be double of the angle at the circle. Angle PAQ. So if this is x, this is 2x, this will be x. And there is another angle on the other side, the reflex angle. This reflex angle will be double of, if you go down here, this reflex angle will be double of, yeah, so this will be now, if this is y, this will be 2y. So I can say angle PBQ is half of the angle at the center, which is reflex angle POQ. We'll be using these properties in all our sums. There's yet another property we are going to use. This is P and Q. Now with the arc P and Q subtends many angles. Suppose I have a point here A, then I will have another point, say B, all points on the circle. Then another point here, say C. Then I have yet another point here, say D. And we have a point here, say E. Now from PQ I draw an angle. So angle PAQ, this is the angle subtended by PQ. Then at B, PQ subtends another angle. This is the angle subtended by PQ at B. Then at C also PQ subtends yet another angle. Then at D2 it subtends another angle. And then at E2 it subtends yet another angle. Now all these angles are subtended by the same arc PQ, and all these angles will be equal. So if this angle is X, this will be X, this will be X, this will be X, this will be X. These all angles are equal because they are all subtended by the same arc. They are in the same arc. That is PQ. This is yet another property we will learn, that angles in the same arc are all equal. So here is the circle, say with center O, and then I have a radius. Say this radius is a chord passing through the center, and I call this radius AB. Now from this radius I will draw an angle at the circle. Say this is C. Could you guess what is the measure of this angle? Now remember, we have learned already that if this is X, this angle will be 2X. Angle at the circle is half of the angle at the center, which means now if we know this angle is now 180, it's a straight angle. So what do you expect this angle to be? This will be 90. And angle ACB is angle in a semicircle. So an angle in a semicircle is always 90. Like if you were to draw on the other side here, this would be an angle at the semicircle. This also would be 90. Angle ADB would also be 90, angle in a semicircle. Calculate the measure of AOC. If you look up here, we have the circle. Here is your center, and we know side OA equal to OB. Why is OA equal to OB? OA equal to OB because they are the radius of the same circle. If OB and OA are equal, then the base angles also will be equal. So these are the base angles. So I can say this angle here, angle A, will be equal to angle B, which means if this is 30, this also will be 30. So I'll write angle OAB equal to angle OBA equal to 30. This is angles opposite equal sides. Similarly, on the other side, we know OC is equal to OB, because radii of the same circle. If OC is equal to OB, then angle C will be equal to angle B, which means if this is 40, this also is 40. So let's write this. So we have now OB equal to OC, that is radius of the same circle. If angles are equal, if sides are equal, angles also are equal. So I can say now angle OCB equal to angle OBC. So write angle OCB equal to angle OBC equal to 40. Now we go to the next property. Now I know this full angle is 30 plus 40 and this is 70. So we have found out that this angle is 70, 30 plus 40. Now this is the angle at the circle. Let us see what is the angle at the center. So we have ABC is 70. Here we will find out the angle at the circle center. This is the angle at the center. So if this is 70, this angle is going to be 140. This is angle AOC will now be 140. So we have angle ABC is ABC is half of angle AOC. Here we have to find angle AOC. So I can say angle AOC is 2 times angle ABC. That is 2 times of 70, which is 140. So angle AOC is 140. It's like what we did earlier. If you remember, here we said if this is x, this becomes 2x. So if this is 70, this will be double of it, 140. In this sum, here this angle is given as 90 and here it is 110. We have to find the measure of angle BAC. So we need to find BAC. This is the angle we need to find out. So first we'll call this angle as x. We'll say angle BOC is equal to x. Now we know 90 plus 110 plus x equal to 360. This whole circle, it's a circle here, and this whole thing is 360. So that's our first step. So we have 110 plus, that is 200, plus x equal to 360. So x is 360 minus 200. So x is 160. So let's mark a 160. So here this angle now is 160. So if this is 160, this is angle at the center and this is 160. Now angle at the circle from here, this would be angle at the circle. From the same points B and C, you get on to the circle. This would be angle at the circle. And if this is 160, this will be half of it, that is 80. So I have angle BOC equal to 160. I need to find angle BAC. BAC is the angle here, BAC is the angle at the center. It will be half of this angle at the circle. Half of angle BOC, which is half of 160. So angle BAC equal to 80. ABC is 69 and ACB is 31. Find DBC. If you look at your diagram here carefully, can you spot a triangle where 2 angles are given? And the triangle is ABC. C. Look at ABC in the triangle ABC here. There are three angles given. Angle B, angle C, and angle A is not given. So let us find angle A. So we start with triangle ABC. A plus B plus C equal to 180. So that is 69 plus C plus A is not given to us. Of course, the C is given to us is 31 equal to 180. So now when you add this up, you get 100 plus A equal to 180. So your A will be 180 minus 100. So A will be 80. So this is 80. And the next step, we will do angle A is equal to angle D. Angles in the same arc. So you have A and you have D, angles in the same arc. So angle A equal to angle D. That is angles in the same arc. And they will be equal. So A equal to D equal to 80. So this angle will be now 80. In this sum again, spot a triangle with two angles. We cannot. There is no triangle with two angles. But we are going to start at this point. Here we have a linear pair. I will mark this as X. So I have 130 plus X equal to 180. That's where I start. 130 plus X equal to 180. So my X is 180 minus 130 and X will be 50. This is step 1. This is linear pair. Now let us spot a triangle that has got two angles. So I rub this and I write now 50 here because I found this as 50. Now look at the triangle DEC. The triangle DEC, in this triangle two angles are given. This is 20 and here is 30. So we have next step, triangle DEC, three angles equal to 180, which is 20, 50, and we need to find this angle D. So 70 plus D is 180. So D is 180 minus 70. So D will be 110. So here we have 110. So angle D is 110. Now if you see angles in the same arc, so these two angles, angle D and angle A, are angles in the same arc. So they are equal. Angle D equal to angle A. This is 110, so this also will be 110. So angle A equal to angle D equal to 110. And the reason, angles in the same segment or same arc. Here in this sum, angles are given as 80 and 120, and we need to find angle BAC. In the first step, we are going to find, this is 360, so we have 80 plus 120 plus this angle, we call it X, equal to 360. So we have 200 plus X, 360. So X is 360 minus 200, so X is 160. So this angle is now 160. So we'll rub this, we put here, we found this 160. Now this is the angle at the center. BOC is angle at the center. So I'll write that angle BOC equal to 160 is the central angle. Now which is the angle at the circle? So from B I go to A, and from C I go to A. This is I do from the same points B and C. Here I go up to A, and here I go up to C, and then I get this angle. So this is 160, this angle will be half of it, and that will be 80. So I write angle BAC equal to half of angle BOC, which is half of 160, and that is 80. This is one part of the sum. Now we need to find also BPC, means this is our BPC, and we need to find BPC. Now to find BPC, this is the angle at the circle. We've got to mark the angle at the center. So from B and P we go to the center. So we have this angle here, and from C also you go to the center, you get this angle. So this is the angle at the center, which will be double. You know, if this is x, this will be 2x. So if angle BOC is 120 plus 80, that is 200. So this angle now is 200. This 2x is 200. Therefore angle BPC, which is at the circle, this angle will be 100. So we have angle BPC is half of angle BOC, this angle BOC. So we write angle BPC is half of 200, and that is 100. Here we have got to find angle ADC, means this angle ADC, and angle ABC, here this angle. So if this angle is 100, it's the central angle of A and C. From A and C you join up here, and this is the central angle. And to find angle at the circle, we have to go to from A and C, we have to go to the circle, and when we go to the circle we will get this angle. So this angle ADC is half of 100. So here this angle will be at the circle, and this will be 50. So we write this. We write angle AOC. Where is AOC? This is AOC, is double of angle ADC. And we need to find angle ADC. We know ADC is half of angle AOC. That is half of 100. So angle ADC equal to 50. Now next to find ABC. If this angle is 100, we can now find on the other side. On the other side we have this angle. So this angle will be 100 minus 360. So we have angle AOC equal to 100. Therefore a reflex AOC equal to 360 minus 100, which is 260. So here we have 260. Now again, this is the central angle of the arc A and C. This is the central angle. Therefore the angle ABC, this angle behind, will be half of it. So this is going to be 160. Remember, this here angle 260 is connected to angle 160. So angle ABC is half of angle AOC, reflex. So that is half of 260, which is 130. Yeah, this is 130. So just to recap what we have learned, here this angle is always connected. Here angle 100 is connected this angle 50, and on the other side this angle 260 is connected to 130. Well, again in the sum, with the angle at the circle is given to us. Here is the point of the circle, and these are B and C. So when you join up, you have angle at the circle, and the angle of the circle will be double of the angle at the center. So that is 50. Here we will have 100, and if this is 100, we know this angle will be 360 minus 100, and that would be 260. If I know this angle 260, if this angle here is 260, therefore the half of it will be here, and this will be angle 130. So angle CAB is half of angle COB, which is therefore we get that as 100. So, or we can say we need to find angle BOC. Angle BOC is double of 50, 100, and on the other side we have angle BOC equal to 100. Therefore reflex BOC will be 260, 360 minus 100, and this is connected to angle I put this as say P. CPB will be half of 260, 130. Here angle AOC is given to us, and we need to find angle ABC. Now angle ABC is connected to this angle reflex AOC. So we have to know first reflex AOC. So if it is given to us that angle AOC is 150, here is AOC, this is 150. Therefore the reflex, this angle here on this side, on the other side, that is reflex angle AOC equal to 360 minus 150, and that would be 210. So this is 210. This is angle at the center. To find its angle, corresponding angle will be this. So this will be half of 210. Half into 210. So if reflex AOC is 210, angle ABC is half of reflex AOC, that is half of 210, and that is 105. Just to recollect, here we have a circle. If we know this angle here is connected with this angle. This is x, this is 2x. In this sub we need to find x. Angle 35 is given to us. Now if you look up here, we know OB equal to OA, and that's because radius of the same circle. So we have OA equal to OB, This is radius of the same circle. So the angles will be 35. If this is 35, this angle also will be 35. So we mark this as 35. So we write angle OAB will be equal to OBA. So we write that angle OAB equal to angle OBA equal to 35. Next step, we take the triangle OAB, that is O, A and B, this triangle. In this triangle there are three angles, and when you add up the three angles you get 180. You see the angles are 35, 35 and angle O. So this angle is 35, here is 35, and we need to find angle O. So 70 plus angle O equal to 180. So angle O will be 110. So this is 110. Now remember, our aim is to find x, and the x, this x is connected with this angle. So we need to find this angle. So first we know angle O, that is angle AOB equal to 110. Therefore reflex AOB will be 360 minus 110, and that is 250. So this angle will be 250. This full angle will be now 250. 360 minus 110. And x will be half of 250. So x will be 125. To explain this, here we have a circle here. If this angle here, this angle is given as 250, we know here will be half, and that be 125. Another thing, notice this full is always 360. So from 110 was given to you, here this was 110, you found the other side as 250, 360 minus 250. Here again we got to find the value of x. So we start out with angles in the same arc. If you see angle A, this is angle A, and angle A will be equal to angle D, angles in the same arc. So that is our first step. So we have angle A equal to angle D equal to 50. Reason, angles in the same segment. Now we have, so this is 50. Now look up at the triangle DBC. In the triangle DBC, we have three angles. We have angle X plus angle 70 plus 50 is 180. So triangle DBC, three angles, 1, 2, 3, equal to 180, which means 70, 50 plus X, and 120 plus X, 180. So X is 180 minus 120, X is 60. So the answer, X is 60. Now for the sum, first we start with angles in the same arc. If you see angle A and angle D are angles in the same arc. Here, this is one arc. Starting, the segment is from B and C. And from B and C, again we have one more angle. So both these angles will be equal. So this also will be 52. So angle A equal to angle D equal to 52. We can say angles in the same arc or angles in the same segment. So angles in the same segment or arc. Now for the next step, you know OD equal to OC, they are the radius. So OD equal to OC, radius. If the radius are equal, the angles also will be equal, which means if this is 52 here, this also will be 52. So we have this angle OCD will be equal to ODC. So now you have angle OCD equal to angle ODC, angles opposite equal sides. So x will be also equal to 52. Now for this sum, here this is 100. PQR is 100 and PQR is connected to this angle, so this will be 200. That is your first step. So angle POR equal to double of PQR, which is 2 times of 100. So this is 200 POR. First step. Now next step is to find angle POQ. I will mark this angle as X. So you have X plus 200 equal to 360. This full thing is 360. So X equal to 360 minus 200. So X equal to 160. So here we have X is 160. Next, we take the triangle POR and the triangle POR. We have OR equal to OP. They are the radius. If OR equal to OP, therefore these two angles will also be equal. I will write the angles as A and A. So OP equal to OR because they are radius, and therefore angle OPR equal to angle ORP equal to, say, A. We earlier have already found out that here angle is 160. So in triangle OPR we have 3 angles equal to 180, angle AA, and this angle is 160. So we have 2A plus 160 equal to 180. 2A is 20. So A is 20 over 2. So A is 10. So the angle A here is 10. So the angle they have OPR. So angle OPR equal to 10.